This is Chapter 2 of Tech Math 2. And we're going to do the chapter review, some of the problems in the chapter review. Starting on page 110. Okay, so we're going to look at problem number 2. And I've got a transversal, and I have two parallel lines. And let's see if I can do that better than that. So I've got two parallel lines, and I got a transversal crossing those two parallel lines. Okay, and then I have line L and M, and L is parallel to M. And I have a transversal T crossing between them. I have angles 1, 2, 3, 4, and 5. And I want to know which angles are vertical angles. So A, the vertical angles are 1 and angle 3. Now there's some other vertical angles, because 2 and the one that isn't marked is a vertical angle, 1 and one that's not marked, 5 and one that's not marked. Those are also vertical angles, but the only two vertical angles that are marked are 1 and 3, and vertical angles are equal. B, I want alternating interior angles, so that would be 3 and 4, angle 3 and angle 4. They're interior because they're between the two parallel lines. They're alternating because they're on opposite sides of the transversal. And 3 and 4 are also equal. Then I want C, corresponding angles. So I want C as corresponding angles. So they're interior, exterior angles on the same side of the transversal. So that in this case it'd be 1 and 4 are corresponding angles. 2 would correspond to the other side of 4, and 3 would correspond to the other side of 5, but they're not part of the problem. Supplementary angles. So the supplementary angles would be 1 and angle 2. Supplementary angles make up a full 180 degrees, and 4 and 5 would also be supplementary angles in this example. Okay, now we're going to look at number 4. And we'll look at 4, and we want to know the area and the perimeter. And what we have is a parallelogram. If I can draw a parallelogram. And maybe what we ought to do is get a parallelogram. Yeah, it won't do that way, will it? So we'll just draw a parallelogram. And I'm 4, 2, 3 meters on this side, 275 meters on that side, and I have an altitude coming down this way, perpendicular, 249 meters. Now, on a parallelogram, we normally say well, we'll go with perimeter first. So perimeter is going to be 2 of those guys, 1, 2, and 2 of the other guys. So 2 times 4, 2, 3, plus 2 times 275. And when we get done, we're going to have meters. And I'll put that in my calculator real quick. 2 times 423 plus 2 times 275, and I come up with 1390 meters, 96 meters. And then we could ask ourselves, how many significant digits are there in the problem? And but that would be not a relevant question because we know these things to a meter, so the accuracy would get us down to a meter. Now, the area of a parallelogram is going to be 1/2 the height. Now, it's going to be the base times the height. The base times the height. So if I look at this parallelogram and I draw another altitude on the other side, my conclusion would be that this guy is the same area as that guy, and if I just brought him over to the other side and put him in like that, I'd have a rectangle that was a base times that height. So that's why I would call it that way. 423 meters times a height of 249 meters. 423 times 249. And my calculator says 105,327, but 0.27. But then I'd say, well, you know, I only have 3 significant digits in my problem. I should probably only keep 3 significant digits. 1,050 meters squared would probably be a better answer to that. Okay, we're going to go down and do number 14 next. Find the area in the perimeter of an equilateral triangle with one side 12 centimeters long. So equilateral triangle is a triangle where all sides are equal. And so that means I have 12 centimeters on that side, 12 centimeters on this side, 12 centimeters on that side. And all my angles are going to be equal as well. So I'm going to have 60, 60, and 60. So that's what I have. Now, if I go and drop a altitude down here, halfway down, I find that this side is going to be 6 centimeters, and this side is going to be 6 centimeters. Okay, so first of all, I want to find, I'll do the perimeter first because that's the easiest. So the perimeter, 3 times 12, 36 centimeters. The area would be 1/2 the base times the height, but I don't know 1/2 the base times the height for a regular triangle. Now, if I was in a trig chapter already, I would just go and say, well, I'd use trig to find the height, and that'd be okay. But if I move back to where my triangles are, see if they have a well, looks like I'm going to have to use Heron's formula. Okay. So what I'm going to do to find the area of the triangle is say I have an S, which is going to be 1/2 plus 12 plus 12. Half of 36 is 18, right? 18. And then I'm going to say the area is equal to the square root of 18 times 18 minus 12 times 18 minus 12 times 18 minus 12. All right, so the square root of 18, 18 minus 12 is 6, times 6 cubed. And then I'd say, well, I could take out my calculator and do something. It would be 3 times 6 to the 4th. So that'd be 6 squared square root of 3. And I might leave my answer like that, or I might call it 36 to square root of 3, or I may have gone and put it in the calculator and done something else with it. But that's what I would have done. I'm not going to do that once I know trig, but I don't know trig yet. I haven't gotten that far. So that's a different issue. Okay, we're back again, if you missed me at all. We'll do number 20 next. And find the volume in the lateral surface area and the total surface area of the solid in the figure below. Okay, so we have something circular top, 13.6 feet. And we have some cylinder type topic, 18 feet. And then we have a cone on the bottom with a peak that goes down to 7.5 feet. And we have 3 significant digits in all of our answer. So the volume of the cylinder is going to be pi r squared, that's the area of the circle, times h. And then the volume of the cone that's sitting on the bottom here, so there's the cone sitting right there, is going to be 1/3 pi r squared h. So for the A part of the problem, where we want to find the volume, we're going to go pi, so volume is equal to pi r squared, which is 13.6 over 2, squared, h is 18, plus 1/3 pi r squared times the h, which is 7.5. Okay, so now it's time to put it in their calculator, but we'll make it a little bit easier before we go on. This is a 6.8. So we have pi 6.8 squared times 18 plus 1/3 pi 6.8 squared 7.5. And then we could make that, well, it's time to get out our calculator. Okay, so I got a pi 6.8 squared times 18 plus, and it looks like I didn't bother to put a time sign by my pi, so pi times 6.8 squared times 18 plus 1/3 times pi times 6.8 squared times 7.5. And the calculator says 2.978 times 10 to the third. And we only have 3 significant digits, so we're going to call that 2,980 feet cubed, because it's going to be a volume. So that would be my final answer for the volume. Now I want to find the lateral surface area. So lateral means the side. So for C, I would say I'm just trying to find the surface area around for D. This is B. B. I'm trying to find the surface area around the cylinder. So my area is pi D, pi 13.6. That's my circumference of the circle times 18, and that should be my lateral surface area. Pi times 13.6 times 18. And we have 3 significant digits, so we have 769 feet squared. And then the total surface area would be that 769 feet squared plus the top, which would be pi r squared plus the surface area of the cone. Okay, well, I'm going to reconsider for a moment my answer to P. Lateral surface area should also include the cone. So the lateral surface area should be the circumference of the circle, pi d 13.6 times 18 plus the lateral surface area of the cone, which would be pi r, which would be 6.8 times s, where s is the square root of the height squared plus the radius squared of the cone. So s is going to be the square root of height, 7.5 squared, plus the radius, 6.8 squared. Okay, so now it's time to take out my calculator. 7.5 squared plus 6.8 squared. I'm going second function square root, second function answer. So I've got 10.1237. Okay, so now I'm gonna go the lateral surface area. I'm gonna start with this number and work back that number. So the answer that I just got times 6.8 times pi plus pi times 13.6 times 18. So I'm going to end up with 985 feet squared as my lateral surface area. And then for total surface area, I'm going to have to add the area of the circle on top. So surface area total, 985 feet squared plus pi r squared. And that doesn't really look too much like a plus sign, but we'll correct that before we go on. And then I got, okay, so I got that answer plus pi times 6.8 squared. And I end up with this total surface area of 1,130 feet squared. Okay, now we're going to go and maybe go on to chapter 3. And I guess we will. So now we're going to move on to chapter 3. And I'm looking at the review questions on page 143. I'm looking at number 2. And we want to change 76 degrees 12 minutes into degrees, in decimal degrees. Okay, so that'd be 76 plus 12 divided by 60. and 12 divided by 60 is 1/5, so that'd be 76.2 degrees. And I could have done that in my calculator, didn't necessarily have to do that someplace else. Also, if you look in the math key on your calculator, there's a degree, minutes, seconds function. So you could go and put in your calculator 76 math, move over to degree, minutes, seconds, degrees, 12, then hit the math function, move over to degree, minutes, seconds, DMS, drop down to minutes, and then hit the return key, and it'll turn your 76 degrees 12 minutes directly into 76.2 degrees. So you can skip that step altogether and just use your calculator to get you there, assuming that you have a TI 36 calculator. Okay, we're going to do number 4 next. Number 4, and I've got 314.3 degrees, and I want to change it degrees to degree, minutes, seconds. Okay, so I'm going to have 314 degrees, and then 0.3 times 60 is going to be 18, so I would put down 18 minutes. And we'll do the same thing with number 6. Number 6, we have 38.405 degrees. So we'll write down, and we want degrees, minutes, seconds. So we'll write down 38 degrees. We'll take the fractional portion times 60, come up with a number. And this number is 24.3, so we call it 24 minutes. We take the fractional part of the 24.3, multiply that times 60, and we would end up with 18, just like we did last time, 18 seconds. And that's how we do that. So we keep the whole part, take the decimal point, multiply times 60 to get minutes, take the decimal portion, multiply by 60 to get seconds. Okay, we'll do 14 next. We want the cotangent of 29.10, and we want it to 4 significant digits. Well, my calculator doesn't have a cotangent function, but I remember that the cotangent of 29.10 is the same as 1 over the tangent of 29.10. So I'd put in my calculator 1 divided by tangent 29.1 equals, and then write down the answer. That's what I would do. 1 divided by tangent 29.1, close parentheses, and I'd end up with 1.797 if I was going to do it to 4 significant digits. So that's what I would do. Going to do number 20 next. So I have the cotangent of theta is 0.9220. Okay, well, I don't have a cotangent button on my calculator, and I definitely don't have an arc cotangent button, but the cotangent of theta, the tangent of theta is equal to 1 over the cotangent of theta, which would be 1 over 0.922. So the tangent of theta, 1 divided by 0.922, is 1.0846. And then I would take the arctangent of 1.0846, and that would give me what theta was. So arctangent of the answer, and I'm going to have 47 degrees, and I want it to the nearest tenth of a degree. Nearest tenth of a degree, 0.3 degrees would be my final answer. Now, we're in chapter 3 right now, so that would be a perfectly okay answer for chapter 3. You put it in your calculator and got the answer. But as we proceed with the book, we're going to find that the cotangent function does this. And so this is 90 degrees, this is 180 degrees, over here is minus 180 degrees. And if you ask yourself, if the tangent of theta is 1.08, and you draw a line there, you're going to have multiple answers. You're going to have an infinite number of answers because the cotangent function continues like that, going both ways to plus and minus infinity. So normally what would happen is that you would be given a range of numbers. So you'd want the answers between 0 and 2 pi. And so you'd have an answer there and an answer there. And then you'd use the idea of reference angles, which we haven't gotten to yet, to find out what that second angle would be. And but later on that we'll have to worry about it. Right now there's no real reason to worry about it. Okay, number 30. And we want to solve the right triangle. Okay, so I've got a right triangle, and I've got an A and of 20 degrees, and I've got a B sitting up there of 70 degrees, because those two guys have to add up to 90. C is sitting down there. The hypotenuse is 1700 kilometers. And so I want to find the little a over here and the little b over here, the side opposites those angles. Okay, well, the sine of 20 is the side opposite, little a, divided by the hypotenuse, 1700. So a is going to be 1700 times sine 20. So we put that on our calculator. And we get 581 kilometers. If we have 3 significant digits. Do we have 3 significant digits? Yes. No. No, we only have 2 significant digits, so we would change it to 180 kilometers. All right, and then we would say, well, the cosine of 20 degrees is going to be b, the side adjacent, divided by 1700. So b would be 1700 cosine 20. 1700 times cosine 20, and that would be 1,597.5 kilometers. But again, I only have 2 significant digits, so I'd have to round that up to 1,600 kilometers. Okay, now there is another way to do this problem. And so if I take my calculator, change the mode to from wherever it is, it might be in real, to a plus bi. So I put it into an a plus bi, which is an imaginary mode in my calculator. And then second function quit. And then I put in 1700 second function complex, hit the 1 for the angle, and I put in 20 degrees, and I hit enter. my calculator will tell me that the B guy is 15975.5, and the A guy is 581.43, and then I would go back and round those out and say B is 1,600 kilometers, and the A guy is 580 kilometers. So there is a better way to do it on my calculator than using sines and cosines, and someday I would expect you to be able to do that too. So what I'm doing is I'm using this as a vector quantity, 170 angle 20, and asking the calculator to calculate the side opposite and side adjacent directly, and not bother me with any of the other math. Okay, now we're going to look at problem number 40, and we want to find the length of x. Okay, so I've got a triangle. It looks something like this. Okay, so I got a triangle that looks like that, and then I'm going to throw in some construction lines. Going like that. That's pretty good. And I've got a right angle there. I've got 25 degrees sitting there. I've got 51 degrees sitting here. I've got 28.5 meters there, and I want to know the distance x. Okay, well, if this is 51 and that's 90, then this entire angle has to be 39. And then this entire, we'll call this guy y, this entire thing from there to there, it has to be the sine of 39. The sine of 39 has to be the side opposite y divided by the hypotenuse, 28.5. So y, 28.5 sine 39. Um, 17.9. So y is going to be 17.9. Okay, well, if y is 17.9, then I can figure out what this guy over here, we'll call him A, is. Because this is Pythagorean theorem, I know one side, I know the hypotenuse, I can get the other side. So A is going to be the square root of the hypotenuse squared minus the side that I know squared. So I have 28.5 squared minus 17.9 squared, and I'm going to find the square root of that, and I come up with 21.18 meters. So this side, 21.18 meters. Now with that side and the angle 25, I can find this side over here, we'll call it y prime. And so the sine of 25 is equal to y prime divided by 28.5, which implies that y prime is 28.5 times the sine of 25 is 12 meters. Well, if that's the case, the whole distance is 17.9, and the y prime distance is 12, so x has to be 5.9 meters. And I am done with that particular problem. And thus ends the review of chapter chapter 2 and 3.